Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 10th grade topic, the remainder theorem. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we saw today or even on homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I've been linking my 10th grade playlist, so if you're interested in that, make sure you stay tuned. This video is only going to have 3 parts, so leave a like, smash subscribe, and let's get started. In my previous video, we covered the factor theorem. Now, if you missed that, no worries, you can find it right up here. However, in this video, we're going to cover something that goes hand in hand with the factor theorem, and that's going to be our remainder theorem. Now, both theorems will give us shortcuts to find something that would take us a little bit more steps to find normally. In the first case, the factor theorem, that was a shortcut to find our factors. And in this case, our remainder theorem, you can kind of guess it, is going to be a shortcut to help us find our remainders. And we don't have to worry about going through synthetic division or polynomial long division. Now, if you have any questions on synthetic division or polynomial long division, no worries, you can find them up here as well. But before we jump into our example for today, let's first talk about what the remainder theorem is. Let's state our remainder theorem. Now, we start with a polynomial, a random polynomial p of x. So we have p of x. If we're dividing p of x by something like this, x minus a. Now, we don't know if this is a factor. I'm not going to call it a factor because a factor would imply that there is a 0 remainder. We don't know what the remainder is. Remember, the remainder theorem is supposed to help us find the remainder. This could be a factor, but it could also not be one. So we're just dividing by this x minus a. We don't know what this is. If we were to do that, our remainder theorem tells us that our remainder, our r remainder, is going to equal our p of a. So simply saying, if we have a polynomial and we're dividing it by some x minus a, our remainder is always going to be that polynomial substituting a in for all the x's, whatever that equals. So if you plug in your a and you get a number, that's guaranteed to be your remainder. Now, I'm not saying that this is going to solve all your problems, because there will be times where you are interested in doing synthetic division or polynomial long division to find your factors. However, if you're just interested in what the remainder would be, this is going to help us without having to do all the extra work. And we'll see how in just the next section. So our first question has us looking at 2 times x cubed plus 3 times x squared minus 17x minus 30, and we're dividing it by x minus 1. And we want to know what is the remainder. We're not curious about all the factors. We want to know what is the remainder when we do this division. Now, normally, you would do your synthetic division or your polynomial long division, but we're going to be using the remainder theorem to see what it is, and we'll use one of those other things to check our answer. So the remainder theorem says when we're dividing our polynomial by something like x minus a, or in this case, x minus 1, all we have to do is plug in our a, in this case 1, here, everywhere there's an x, and see what we get. So by doing that, we're going to have 2 times 1 cubed plus 3 times 1 squared minus 17 times 1 minus 30. So we're plugging in, so if I was to call this p of x, we're plugging in 1. This is going to be p of 1. Now let's simplify everything. So this is going to be 2 plus 3 minus 17 minus 30. And that's also equal p of 1. And what do you get when you add all of this? So this is going to be a 5 minus 47. And you're going to have a negative 42 equals our p of 1, which equals our remainder. We have a negative 42 as the remainder. Now, at this point in time, you may think, well, how do I know if this is truly the remainder that I would have gotten? Well, let's test it out. So we're going to remember that this was a negative 42. Matter of fact, I'll just write it up here for us. So we knew our remainder is going to be our negative 42. Now we're going to do some long division. So we have an x minus 1, and we have all of this, 2x cubed plus 3x squared minus 17x minus 30. And we're going to do our long division, which means we're going to have and you can see that doing our polynomial long division, we do in fact get a negative 42. So we did all this work here when all we had to do, according to our remainder theorem, is simply plug in a 1 into our polynomial. We would get the same result. If all you're curious about is what is the remainder, simply plug it in and see what you get. So let's jump into our next example to get a little bit more practice with our remainder theorem. So in our last example for today, we're going to be looking at the same polynomial, but instead we're going to be dividing x plus 2. Instead of x minus 1, we're going to divide x plus 2. So let's see what we get when we use our remainder theorem to determine our remainder for this example. Now don't get tripped up. It's x plus 2 this time. Remember, it was x minus a, and then you would plug in your a. But this is a plus 2. So if you were to try to find our a, what would it be in this case? Is it going to be a positive 2 or a negative 2? Well, it's going to be a negative 2 because only when a is negative 2 would you get a plus 2 here. So don't get tripped up with that. Make sure you're plugging in the right thing. We're going to be plugging in a negative 2. So when we do that, we're going to get the following. And when we simplify all of this, we're going to get the following. Notice that when we plug in our negative 2 everywhere and we simplify as much as we possibly can, we get negative 46 plus 46. It cancels out, which means our remainder is going to be 0. So based on our remainder theorem, we in fact found a factor of this polynomial because the remainder was 0. But just like last time, let's make sure we check our work to make sure we didn't go wrong anywhere, that we did everything that we would need to do and we did it correctly. So we're going to have 2x cubed plus 3x squared minus 17x minus 30, and we're going to divide that by our x plus 2. So when we do that, we're going to have the following. We in fact do get 0 as our remainder, which once again means that this is a factor of our original polynomial. But we didn't have to go through all of this to determine that. We can just use our remainder theorem and we would have seen that. So I hope you were able to follow along with today's video and hope you now understand how you can use your remainder theorem to find your remainders without having to resort to your synthetic division or your polynomial long division. But if you have any questions about what we saw today or even your own homework, remember you can put it in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping to help with your homework. I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.